Hello. As you may remember, my name is Rafael. In today's episode, we will deal with a topic commissioned by one of our clients. We will check the rotating joint, also called a swivel. To show what this part does, I will use an example of a slightly simpler solution. It is an element that allows us to lead two water pipes under high pressure to this device, and with two connected tubes, we can rotate them. So we can transport water under high pressure while being able to rotate this element. How does it differ from this? Well, here we have one axis of rotation, while in this specimen we have two, thanks to which we can make a complex movement with the so-called scissor system, which we can show on the machine in a moment. We can transport water under high pressure from the pump directly to the head while maintaining a compact high system pressure, which, although it may look complicated, has many useful features. What I'm holding in my hand is the latest design of this connector. It has undergone a certain development from the first and second to the present generation. The defects and imperfections that were noticed and reported by users were corrected. And we have reached a stage in which these connectors are really durable. As soon as a leak occurs and we notice and remove it, we can extend its lifespan and use it for up to a few hundred hours of operation on our device. Before we dismantle this element, as this is today's mission, we need to check what's wrong with it. So we'll install this component sent to us by the customer and place it onto our demo machine. We will run a pump test to locate potential leaks or irregularities, and only then we will start trying to eliminate them. Now a few words more about the system itself. At first glance it may seem that this is a system that simply complicates the machine, introduces more costs, which only hinders our work and could cause additional problems. That is of course completely untrue, as this solution has many advantages. The fact that we have a slightly smaller curvature of this machine is the least important of these features. It is a feature that is only an additional attribute to the original assumptions of this system, namely the scissor system, which, as you can see, includes scissors and tubes and the rotating joints that we will be dealing with today. The premise for the creation of this system is the fact that Omax is constantly seeking to improve their machines. As far as I know, only Omax machines have such a complex scissor system. The concern was, above all, safety, plus the transfer of hydraulic power to the cutting head. If you compare this solution with different popular solutions available from other manufacturers, which is usually called the so-called bat or fishing rod, and probably has many other names, we'll see that the main idea is that the system is an alternative system with a long tube, as you can see on one of our other machines. So it simply replaces one flexible long tube that leads water directly from the pump to the head. At first glance, the complex system allows us to have two things. First of all, an increased level of safety, because when loading a material while operating the device, nothing which transports water on high pressure rotates overhead. The second aspect is that we can use pipes with a larger diameter. A large diameter means more water and a more accurate transfer of hydraulic power to the head. It's an aspect that no one thinks about because we use 3/8 inch pipes here. In the solution I mentioned, that is, with the so-called rod, there is a much thinner tube, namely 1/4 inch. And naturally, less water will be delivered per minute through a tube with a smaller internal diameter. Another aspect is especially valid when we deal with larger models, because the larger the machine, the longer the rod needs to be. When this tube fails, and we know every element may at one stage fail, then the transport of such a tube is a huge cost with a long delivery time, because the element has to be delivered in one piece. In a situation where we have scissors, we can deliver the tubes, made in shorter sections, faster and cheaper, and, above all, it is easier to replace such components. The first one has been checked, and as you can see, depending on the way they're made, they can be found in different places of the machine. Now we'll check this one in this connection and check if there are any leaks and what we can do about it. We've tested a rotating joint, and in both cases, that is both of these components, showed a leak in the same place, exactly through this control hole. In this diagram we can see that water can get out through this hole when there is a leakage in this connection. If you look here, this connection is created by this element, this body, and the seal between them. What can fail? Of course the sealing may fail, but it's also possible that one or the other element is damaged. And in a moment we will check what is the cause in this case. We have already finished the entire operation, and our assumptions were confirmed. In both cases the defective seals, damaged after the replacement and testing, were to blame. The components are operational and ready to be used. In reality you can perform the repair by yourself. The instructions how to do this are available on the manufacturer's website. We encourage all owners of the machines to register there and to use the large treasure trove of knowledge that can be found there. See you in the next episode.